First thing is to load everything into memory. And I was like looking at my code, suffering, trying to get the cache text to work, and I was like, oh yeah, let's go get my other code and just look at it. Then I was fixing things and I found something. There's this cool website, and what it really is inspiring, besides all the curl stuff and other stuff I found, let's see, the system information discontinued. So there is a GitHub for system information. The reason that this is like relevant, oh wow, supported OS is everything. Practically everything except for, you know, retro computers that I saw on Facebook today. Even though it's possible to do those too. I remember how to, or I sort of remember how to use debug on Windows 95. And you could go into the low memory space of the stack or whatever and just kind of print out what's in the BIOS. And that was the way you could get total use memory, total swamp, these type of variables. So I would like to, it's programmed in Rust, it's funny. Okay. Class system information. I would like this to be a part of life or something, part of my glorious project. But there is stuff like CPU info. Oh, what was that? So there's different versions of the sysinfo out there. And they're nice. I mean, some of them are scratch projects, and I guess some of them are more. So because the first call I'm making, I need a big block. I was thinking just get 256 megabytes of memory. Now for the Raspberry Pi, that's going to be much. Maybe we should do, because it's like, okay, I know there's a way to do it with the Vulkan driver or something. We could ask Bard real quick. Uh-oh. Computer is processing. A lot of lag. I see mouse lag. Okay, so, I mean, usually the development machine is a little more beefy than your average cheapo gaming machine. By that I mean, teenager got his first car, gaming machine, same difference, and there is no like CUDA and ray tracing. It is just like bare bones, and you could run Windows 7. You're an elite hacker. And that's the thing I looked up also yesterday. I was trying to compile curl. I didn't get it to compile. I almost did, but there's some sort of other problem with the last stage of the resource linker not working. I got to solve that. It's like an ongoing process with some other IT support I'm doing. And the IT support I'm doing, I'm trying to run this other program, and I have to register DLL, so I have to do something very hacky to the system to get some program to run. And yeah, you get into kind of like, why is .NET not working, and like a bunch of drivers on Windows 7. But Windows 7 is nice because it's really stripped down. It'd be nice to get into Windows XP. I don't know if I have time for that. So how do I make the graph look different? Anyway, change graph to single engine. Okay, yeah. So half my VRAM is being used. On average, it's going to be just taken. So I have 4 gigs. And this 72 thing, this doesn't really count. It never goes over 8, really. I noticed. So I felt like taking this number, which is 256 bytes, or floats, or whatever, and dividing it by 2 initially. That would be my initial number, 128. megabytes of VRAM. And kind of a humble way to get started here. Can it even take this? I want to have this side note here. VRAM max is equal to get VRAM max. And I don't have this function yet. I would need to make it. Load up a side library that'll go and like do some sort of system call to the kernel or something and ask it. This info and so convenient. Support my work. Okay. Subscribe to the channel. More notoriously social networking quotes. Follow my Patreon. I need to actually do all that Patreon stuff for my other game. I need like followers because like the game is cool. It's like really fun. My RTS game is more like a learning side project, even though it has great potential. Yeah, so there's more of these gists in GitHubs. Okay, this is more of a Python implementation. I would want just like C, but C++ is fine. As long as it's like C89, no, I'm kidding. Anything like under 21 is fine, I think. C++ 11 is good. I was dealing with the JSON library yesterday for calling Discord API and Windows 7 after I got the curl to work, but guess what? It needed SSL. I got SSL to work, or TSL 1.1, and I downloaded the prem file, the certificate file off of curl, the official one. How I got the curl was industry secret. Somebody private messaged me. Maybe I'll tell them, depending on who they are, because I don't want the spammers to have it. Yeah, because if you could run curl, the latest version on Windows 7, that's like intensely cool. It's intensely fast. That's what's going to happen. You can really utilize like a shitty computer. I'm just seeing if they have the stat I want. They don't. I mean, it's good to know how much RAM you have, but it's really good to know how much VRAM you have. You don't really need a lot of RAM for a game unless you're doing a lot of stuff, which it kind of will be. Look at these dinosaur computers. I mean, they're not that bad, but most people would just frown upon these stats. Well, 8 gigs of RAM, it used to be good. Yeah, 8 gigs of RAM can do good on a Windows XP. Or these, like, lower Mint systems that, like, everything's got drop support, which is annoying. Because they run just as fast as these bloated new systems. Ubuntu 24, all this, like, super... I don't know what that thing is running, but you can type commands and get everything installed in like 2 seconds, but your Google VM is still going to have 2 processors. Yeah, this is all Linux. Can't do this on Windows. Even though there's like Windows system information, you can just run like system. Let's see. Do this. Code in C, Windows 10, get VRAM. I think I've done this for OpenGL. Like I was trying to do this on a unupdated Windows 10, just to see if like Visual Studio 2012 or 2010 would give me this value. So here, yeah, he's using DirectX driver. Okay. DirectX graphics infrastructure. Yeah, linking against this can be futile. Why? Because I have a sample. And I need to install the Windows 7 SDK. I do have a copy of it on the Windows 7 computer. Now, I'm trying to get this driver to work. You can see my linking errors here. The problem is it unresolved external to VS Visual string formattation of these libraries is not there. So it's like trying to link something after it links to it. Really annoying because it's just for a basic shader tester for Source Engine. Now how this is relevant is because of the VRAM. So I have another thing in my source code here for my source 1 game. This thing called the main menu live shader editor, or I'm coming up with the name, but it's definitely like over the top cyber technology compared to Gmod, where you could just switch out the your materials on your or textures on your models. And here, so it gets interesting. Whenever I try to call some of this, obviously I get like I've gotten it to like show just black screen of nothingness, I call it, of the void. Like it'll just open the void, and you're like, okay, I just completely screwed myself up. So it gets the mode info, device info. This is sort of like getting the device in Vulkan or something, and like enumerating it, and then finding out your stats, what you're working with. Yeah, so all of this just for the simple first step of memory allocation. So I'll get back to this later. Now I'll work on this shader thing too, because I'm really excited about having a shader thing. I'm just gonna do the ghettoist approach, because here I'm just like invoking getting the DLL interface right out of the engine. I'm trying to at least, but this is like rock written code, and I've got 2 versions of it. And I fix things up, patch things up, and there is things I think I'm doing completely wrong. Like it won't let me just switch the device. So once I do, I just screw up the game's rendering. I can't like initialize another mode once it's been initialized, and the engine doesn't want me to get in there and get the context. Like they don't want you to steal the context of the renderer, I guess. Maybe they do, but who knows? It's just maybe my bad. There's also the source tools shader editor by Biohazard. I've been looking at implementing that and using the code out of that to do what I want. And it's a little jagged toward the approach. Yeah, this is the iShader device thing I kind of spewed from the AI. But it has most of the basics. It has shader compile, geometry shader even, create vertex shader. So it's like kind of like your normal shader class in like OpenGL, in a sort. Does some buffer stuff, util buffer. But what we need is just, hey, what's the VRAM? Because we just need to know how many vertices we can pump into the thing. Okay, so let's say like we know our VRAM amount. So we're going to times that by the float. Yeah, back from my Kulo 2D platformer code. Okay, this will be whatever that times float. So if this is 4 times more of 128, it won't it'll just be what, 512 RAM, and it'll of course take 512 RAM from the application initially. And if it fails, it's bad, because if the person's running way too many programs somehow, this is really gonna like, really like jerks the computer here. So, okay, let's say we initialize this like this, because we need a straight up linear thingamabobber, linear memory allocated, so that way we could keep using subbuffer data on it if we have one VBO. And we can make parts of it updatable. I should have the code for that somewhere too, but really it's better to just like write a class right from the get-go, because this is what you end up with. Just like multiple functions trying to send stuff to buffer, and it just gets really bad. And it's really hard to read the code after a while. Okay, so INIT graphics ReRAM. And the way you work with this, you could just increment dynamic. I'll try to do the code here in a second. And yeah, this is kind of like the raw method. But then what are you going to do? Keep modifying this, but you can't make it longer. And if you try to make it longer, you run into problems. You could also have a vector. But what's the difference between a vector and a malloc array? The vector is going to be a little bigger, I guess. All right, so what we need to do, first things first, let's deallocate this madness. Let's write a free function. There's also realloc, and I looked into that yesterday. So Windows does have a realloc function. Some systems don't, because I was doing the JSON file, and JSON's interesting because it has all sorts of, I call them contrarian things for all the operating systems. Like one has a Boolean, the other one doesn't, and then if you include Windows.h, you get Boolean, and then the variables collide, and min-max collides, and all kinds of collision problems with the code. Or I just quickly like patched it up like in 15 minutes. I was like, oh, well, I can't generate this file with CMake. It doesn't let me for whatever reason. But I could really quick just change like 20, 30 constants and just fix the code up, because Grok wrote some really weird stuff, but I knew kind of, it's like, oh, okay, so I just need to parse because the JSON code was good. How Grok used the JSON code was not good, or barred, or whatever. But I've done it so many times that I was like, okay, don't even like use the AI, just like do it yourself. It'll be done by the time you know it. It'll be faster than watching the thing paste back to you super fast. Yeah, so you could code faster than the AI. It's just, forget about it. All right, so we need to replace this garbage. I'll just show off a little bit of the code I have that I initially. Okay, so this is AL game box 17 version of my Kulo game. And I have very primitive structures here, like level boxes. And I set up everything statically, very spaghetti-like. I even had like transformation matrices within the structures of the objects. A lot of reference. So what all we need here is a basic INIT function. So one of the ways I did it was like I did use one of these structures, and then I just mem-copied this. That's one way. Because it's easier to like predefine it. Like, okay, we're gonna need like a little interface, just pre-populated. And then what you do is you take this and you increment it. This is how you do it. Vertices dynamic. And then you save. You save the offsets and you pump them into a class. And so like it'll be your first 3 or first 4 coordinates is your XYZW. And then it's usually your texture coordinates, and then it's like your type, and then it's your color, your normal, your what is it? Your tangent or whatever. It depends on what kind of shader you want to run. Sometimes it can be like both, and then the type determines what the shader does with the Uber shader. So this is heavily reliant on the idea of Uber shading, and Uber shading just means there's like a type, and it shades differently depending on the thing, and it vertex differently. So you could have 2D and 3D, and possibly multiple camera viewports, so you could have like multiple uniforms for camera, multiple uniforms for lights or something. Yeah. I guess you could put the lights into the the sampler object. Like you could have one sampler object be the texture, one sampler object be the normals, one sampler object be the lights, and one sampler object be like the tangents or something. And maybe another sampler object for instances. So you're getting like 35 samplers. That's a lot. You know, like Raspberry Pi would probably not like that. Unless everything was small. You know what I really need to do here? Just search this, find the best, closest, ideal. Okay, so it allocates it here. Dynamic box. And it's possible to also support triangles and non-quad thingers. Yeah, this is where I was like updating stuff. Figured out, oh, I can dynamically update the buffer. It's just really sickening on how I managed to do it, but it's OpenGL. I guess in any kind of... Alright, let's just take this block. Okay, predefined VAO. This just does our initial GL vertex arrays, GL buffers, VBO, GL vertex array, and GL VBO. So I'm doing draw call triangles. Now it is possible to do elements. So we're trying to have this really simple. To where like it'll run like on a trash can. Part 1, graphics alloc. These two functions actually do the same thing. This one does part 2. Now we will need more vertex attributes. I believe it would be good to do that right now. But really, right now, we just need to do the simplest thing. Which is just like get some blocks on the screen, then some text. And then possibly tiny GLTF 3D model. So I prepped that. I don't know if I showed it last time. What happened? Yeah, so we got our cube. We still need to export cube number 2, or number 3 now, and how you look at it. And so, 9 is stupid. Okay, we need to update one thing. Oh no, there's only 1/6, there's no 9. Sorry. I forgot cubes don't have 9 sides. They have like 6 or something. Yeah, 6. Going crazy here. But if it was different primitive that had more sides, like the octal thinger, then we would need to put a line under it in order to make it so we can determine the difference between side 6 and 9, because they usually, in most fonts, look same. It's like, oh, how do you tell? Oh, it's siding to the side or something. I don't know. Okay. So we need another one of these allocator functions. We should put it right under the first function we call. The first function we call is VRAM allocator. This is so confusing now. And we need some of this to stay around so we can modify it later. And this is the insane part. It's like having this. Okay, so we allocated the VRAM. Or this is like not allocating the VRAM. This is just pre-allocating how much VRAM we're going to have. But it's on the CPU side. NIT predefined VBO2. So we're just, yeah. And this is where we got to throw some stuff in there. Instead of vertex text, we're going to redo this function again. Or I am, but INIT, let me make it INIT int void predefine VAO. From CPU, I guess. Return 0, success.